In this video, we'll be looking at Chapter 10, Section E, on the area of a triangle using sine. Let's consider the triangle shown. Notice that we have three angles, A, B, and C, and we have three sides, also A, B, and C. And notice that the side A, which we denote with a little a, is opposite angle A. Likewise, side B is opposite angle B, and side C is opposite angle C. This is pretty standard convention for most triangles, so you should get in the habit of labeling your triangles like this, with opposite sides in the lowercase letter of the angle. Now, if we're interested in finding the area of this triangle, we have to recall from geometry that area is equal to 1/2 base times the height. Well, in this case, our base is side C, and our height is h, which is denoted by the line from C to N. Also notice, though, that we have a right triangle here. The right triangle ANC. Also notice that if I was to take the sine of angle A, I would get h, which is the opposite, over B, right? So the opposite side over the hypotenuse. So I have sine A of angle A equals h over B. Doing a little bit of algebra here, multiplying both sides by B, I get h is equal to the sine, h is equal to B times the sine of A. Now if we take this value for h and we plug it in to our previous equation for area, we get a new equation, and that is area equals 1/2 C times B sine of A, which we can rewrite as 1/2 BC sine of A. So now I no longer need to find the height of a triangle to find its area. If I know two adjacent sides and the angle between, I can calculate the area. It follows that I can write equations for the area using the other sides and the other angles. I could also write the area as 1/2 AB sine C, or 1/2 AC sine B. And these will all get me the same area. So to quickly recap, if I have a triangle and I know two sides, and I know the angle between those two sides, then I can find the area using one of these three equations. So let's take a look at an example. Here we have triangle ABC, and we're given two sides, side AB and side BC, and we're given the angle between the two sides. And we're asked to find the area. So remember, I can use one of my equations from the previous side. In this case, I know side C, and I know side A. So my equation will be 1/2 AC times the sine of the angle that is between those two sides, which in this case is angle B, but I know the value of angle B. So I can fill in all of these variables. I have 1/2 times 11 times 15 times the sine of 28. And if I plug that into my calculator, I get approximately 38.7 centimeters squared. Now take a look at the units really quickly here. Notice I have centimeters squared. That's because I'm finding area. That's because I'm really multiplying centimeters by centimeters here. And sine of 28 is unitless, so I have centimeters times centimeters, which is centimeters squared. That makes sense when I'm finding an area, and so you should get in the habit of writing your answers with the appropriate units. Here's another example problem. We're given triangle ABC, and we're given side AB, which is 13 centimeters, and side BC, which is 17 centimeters. And this time we're given the area of the triangle, which is 73.4 square centimeters. And we're asked to find the measure of angle ABC. In other words, we're asked to find this angle here. Let's call it theta. Notice that we're dealing with two adjacent sides and the angle between them, plus we have the area. So I can write an equation here. Area equals 1/2 side A times side C times the sine of the angle between them, which in this case is angle B. Now I know area, I know A, and I know C, and I'm asked to find B. So I want to get B alone here. I need to do a little bit of algebra. I'm going to multiply both sides of the equation by 2. I'm also going to divide both sides of the equation by AC, so that I have sine B equals 2 times the area divided by A times C. Now I still don't have B alone, so to get B alone, I'm going to take the inverse sine of 2 times the area over AC. And now that I have the equation rearranged, I can plug in the numbers. So I have sine of -1 times the inverse sine of 2 times 73.4 divided by 13 times 17. And this is approximately 41.6 degrees. But I have to be careful here because I'm taking the inverse of sine. And remember from our unit circle that sine really has two values, or there are two angles that could get me this same sine value. The first, which is 41.6, gets me a sine value here. But if I draw a line straight across, I know that there's another angle here that would get me the same value for sine. So to find the second answer here, and remember when we take the inverse of sine, we usually have two answers, or we always have two answers between 0 degrees theta and 180 degrees. To get the second answer here, I subtract the 41.6 from 180 degrees. And my second answer is 136.4 degrees. And again, that's because this angle here and this angle here have the same sine value, and my calculator only gives me the one between 0 and 90 degrees, so I need to use the unit circle to calculate my second possible value for the sine of theta. Now sometimes this extra value will be an extraneous solution based on the geometry of the triangle that's given, but we'll take a look at that as we continue to move through the chapter.